Now, when we're talking about exterior angles, it's a little bit easier to see if we start out with a regular polygon series like a triangle. If the inside angle here is 60, 60, and 60, the exterior angles are 120, 120, and 120. So the three angles added up would be a total of 360 on the outside. Same thing for the square. Square has 90-degree angles, which would mean that the outside exterior angles are also 90, and there's 1, 2, 3, 4 of them. So four 90-degree angles make a total of 360 degrees exterior angles. Pentagon, same thing happens. If I did the n minus 2 formula, you got 108 degrees for each one of them, a total of 540 inside, which would mean that the exterior angles are 72 degrees each, and there's 5 of them. And 5 times 72, guess what? Again, 360. So if I wanted to figure out what it would be for a hexagon or a 18agon or whatever it may be, all I have to do is take 360, as long as it's a regular shape, and divide it by how many angles there are on the outside, or how many sides there are in the polygon. So if I had 6 sides and 360 degrees to split it up between for a hexagon, that would mean each angle on the outside would have to be 60 degrees. And if I add up 60 times 6 is 360. And this way I can also remember that a linear pair is 180, so each angle inside is 120, and figure out that 120 times 6 is 720, and I didn't know that I did it correctly. So, and this is the kind of a picture-wise of why all of them have to be 360, because you can put a circle around it, and we know circles have 360 degrees. And this is what the words are for the polygon exterior angle sum theorem, is basically what we just said. Forget about the names and just write down a sentence. The sum of the exterior angles for any polygon, as long as it's convex, is 360. So let's see if we can do some harder problems with this. Find the measure of each exterior angle of a regular dodecagon. Regular being a key word here. Exterior, so we know we're not using the n minus 2 formula, and we're just using the 360 divided by n. Since it's a regular, we can use this little formula. Dodecagon, meaning n is 12. So 360 degrees divided by 12. Each angle is 30 degrees. Each, another keyword, outside. So 30 times 12, total of 360. That one's done. Now we see that it's not regular, but they give us the 4 different measurements. This is a quadrilateral here, so we know that n is 4. And if we use our little formula, 360 divided by 4, we get 90, but we know that these angles aren't 90, 90, 90, and 90. So can't really use that formula. But we know that all of the angles added up, 4r plus 7r plus 8r plus 5r, have to total to, well, these are exterior angles, so it has to total 360. Simplify this a little bit. 11r plus 8 is 19r plus 5 is 24r equals 360. Divide by 24, we get 24 goes into 36 one time with 12 left over. And 24 goes into 125 times, so r is 15. Find the value of r, so we're done. If we need to find each angle, we just plug 15 in for these four, and we would be done. So in summary, if I wanted to find the sum of the angle measures, and we're talking about interior angles, we're doing the n minus 2 times 180 formula. If I wanted to find it and it was exterior angles, I just write down the number 360 and be done. If I wanted to find one angle measure or each angle measure, and we're talking about a regular polygon, and we're talking about interior angles, now we just take that n minus 2 formula and divide by the number of sides. If we're talking about exterior angles, we take the 360 formula, or just the number, and divide again by the number of sides. So here we have a couple harder problems even. Name the convex polygon whose interior angle measures have each a given sum. So given sum means that all of them are added up together, no division. And this is interior angles, so we're looking at using this formula right here. So they already give me the answer. I'm just going to set up the formula n minus 2 times 180 and solve the formula. If I divide by 180 first, I don't have to distribute it in, which would make the numbers really nice and easy. 180 goes into 1800 10 times, and I just have this n minus 2 over here left. So what minus 2? Well, n would have to be 12, so this would have to be a dodecagon. Do the same thing right here. I'm going to give you a minute to do that. So if you divide by 180, we get 14 equals n minus 2. So what minus 2 equals 14? Well, n would have to be 16. So this is a regular 16gon. Easy enough? Good. Let's try this one. An exterior angle measure of a regular polygon is given. So keyword, it's an exterior angle this time. So regular polygon, meaning it's possibly they're giving us an angle measure, one angle measure. So this is the column we want to be in, this row we want to be in, this is the column we want to be in. So we're using this formula right here. So if I take this 120 equals 360 over n, I could set this up as a proportion, cross multiply, and get 360 equals 120n divided by 120, and I know now that this means n is 3, so this is a regular triangle. Go ahead and try this one. This one should be really easy. 360 divided by n equals 36. What's n? Probably do this one in your head. That's right, n is 10. So this would be a decagon. Start to use these words as you are going through this section and this chapter, and this chapter will go a lot easier. Also, don't forget that your homework, the last page in the packet that you got yesterday, is due tomorrow. Make sure you turn that in when you first come to class. Make sure your name is on it so that you can get credits. Hope you have a good time, and if you have any questions, feel free to email me.